All right, can everyone hear me? Or would you, anybody in the back, prefer I actually use the microphone? We're good? I don't like microphones mostly because then I actually hear what my voice sounds like. And I generally think it sounds pretty silly, so at least with the reverberation in my own head, it sounds normal to me. So I'll just keep going like this. If it ever, at any point gets too quiet, let me know. Just yell at me. Welcome to my talk about micro frameworks make awesome APIs. My name's Austin Morris. You can find me on all the things as Austin S. Morris, including GitHub, where I have a repo with GitHub pages that's actually posting these slides if you want to check them out later. Quick disclosure, I would rate this talk at least intermediate. We'll go through some mostly high-level architecture, and then when we get to code samples at the end, I'll probably be whipping through them pretty quick. So you should be good, pretty good with most PHP syntax, functions, closures, array access, method chaining, things like that. Will make it much easier to follow along. So a little bit about me. I PHP. That's why I'm here. I first started dabbling in college in the early 2000s. I'm not going to give you an exact year so you can guess my age, but that's when I got involved. For a while, I mostly did personal projects while I was masquerading as an aerospace engineer. That was actually my major in school. I worked in that field for 8 years before finally coming to the realization that that stuff was boring. This stuff is not. I'm going to do this, and I've now been a full-stack developer for the last several years. For money, I am a senior software engineer at Varsity News Network. That's relevant for two reasons. One, we're hiring. We make software to support high school athletic departments, so if that sounds cool to you, check us out. But secondly, and almost more important, we do the things in this presentation. So we have an API that serves thousands of schools with tens of thousands of sports teams with hundreds of thousands of athletes on those teams. So when I talk about some of these things in this presentation, I know this works because we're doing it at scale with a giant pile of data. I also love open source. I'm the co-author of Peridot, which is the highly extensible, highly enjoyable BDD testing framework for PHP. Feel free to click that link on the slides and check it out if you weren't at my presentation about it yesterday. Also, it's how I test the things that are in this presentation. So you won't see any actual tests around it, but know that it's been tested and I've done it with Peridot. So let's jump into the point of this talk. I want an API, but I've heard from all my friends and colleagues all their disaster horror stories about terrible APIs, so I want to make sure my API is awesome. Okay, well that's not much of a requirement, so we need to start talking about, well, what makes an API awesome. So an awesome API is domain focused. An API is not a self-fulfilling prophecy. Nobody builds an API because they want an API. Just like nobody builds a website because they want a website. You build a website because you have information to share with people. You build an API because you have data or information to share with, well, people don't read APIs, with other computers, indirectly people, but you've got something to share, and that's what your API is for. It's going to focus on your business. My domain is my business, and my business is my domain. So while we talk about all these things, just remember, whatever that business is, whatever that information is that we're trying to share, that's what's most important, and an API is just a wrapper around it. An API supports the domain by providing access to that data, allowing you to take actions on that data, and applying the rules of your business to those actions and that data. That's how the interactions, that's the reason for the interactions, but how should people interact with this API? Well, in case you've never heard of it, there's this thing out there called REST, and it's generally regarded as pretty cool. So I'm not going to go too far into this. I like to think of REST as just a best practices way to approach information sharing over the web. And without getting into great detail, I like something called the Richardson Maturity Model. It's a measure of your API's RESTfulness, but it's a good way to look at where you stand or where you're trying to go as you put together an API. And in this context, it's useful to think of your restfulness from the client perspective, whoever or whatever is actually consuming your API. So at RMM level 0, this is where everything sort of starts or started. We have what we call the swamp of POCs. This is the kind of API where you have a single URL and you would either post or get anything and everything you do with an API went through it. This is often referred to as remote procedure invocation, but imagine saying get API and passing in, or post API and passing in a body that says list me all the products. That's kind of the basic first attempt at an API. And it really stinks. That's why it's level 0. It doesn't even get a number. That's such a crappy API, you don't even get to call yourself level 1. To get to level 1, you have to at least start thinking about your data in terms of resources. And this is where we start splitting out URLs and having different resources accessed at different points. So think of a products endpoint, an orders endpoint if you're doing e-commerce. You still end up posting everything and saying, well, give me an order, or place an order, or show me all the orders in the past. That's not very good, but at least we've started to divide and conquer this complexity with different resource endpoints. When we get up to level 2, we have what we call protocol standardization. And this is where we use the underlying HTTP protocol to even further break down the complexity of the API. It's really the HTTP verbs. If I want to get a single resource or a collection, I use get. If I want to delete it, I use delete. If I want to update it, I use patch and post to post to a collection. So take advantage of the protocol to make the API itself less complex. Then there's this magical layer called level 3, where we talk about hypermedia as an engine of application state. And that is a way too fancy way to say, put links in your response so people know what to do next. And that's cool because it allows discoverability and automation. So in talking about Richardson maturity level, we have the first requirement we're going to place on our API, or rather our framework when we're deciding how to build an API. When we combine level 1 resources with level 2 HTTP verbs, we obviously need a router. Now that shouldn't be too surprising, that's pretty basic. We haven't done anything earth-shattering yet, but just be aware that if I'm going to choose a framework to build an API with, it better have a router. Hint, every single one does, so don't worry about it yet. But what about level 3? Well, level 3 is really part of your API design. It's a requirement of the API, not of the framework. So unfortunately, you're kind of on your own for that part. So what else do we need? An awesome API has to be well tested. I'm not going to go into why you test it. Please be testing your code. The tests we like are unit testing. Anytime we can get down to the unit level to test something, it's typically faster, more stable, more reliable. As a fallback, we can do higher level integration or functional testing, but be warned, this can be slower, more fragile. Our code is easily tested when it's isolated and singular in purpose. So think how easy it is to test a couple lines in a function in a class, as opposed to some giant monolithic piece. If we can break down into these like little single pieces, it gets much easier to test. Code is easy to test when external dependencies are injected. So if you're depending on a database, some other web service, a caching layer, if that dependency is injected at the constructor through what we call dependency injection, when we get to our testing, we can mock that and make the actual unit piece easier to test. When I say mock, having put this talk together before I then said in Yitz's talk, you were in here. So with apologies to him, it's not all just mocks. There could be doubles, stubs, mocks, spies, and like 3 other things that are all different. And code is easily tested if each thing you're testing has a simple public API. So use encapsulation, use protected and private methods and variables, hide that stuff which other people don't need to know about, test that public interface. So the other thing, kind of goes along with testing, is an awesome API is maintainable. Well, testability and maintainability go hand in hand. Maintainability is typically associated with using good software design principles. We prefer loosely coupled objects that depend on abstractions. We like small, highly cohesive objects with a single responsibility. We don't like to repeat ourselves. We keep it simple. We like solid principles. Yada, 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 many, many more acronyms. But between these two things, we've stumbled on requirement number 2 for our API. Something has to inject all those dependencies, so we need an inversion of control layer. From here forth, we'll just call it the container, but this is typically the layer of software that's going to handle our dependency injection. This container gives us access to our domain services. So remember, our API is a web accessible layer over the rest of our software in our domain. We're going to use it to access code independent of the actual API itself. The container will resolve our dependency abstractions. Think inject an interface, but then resolve it in the IOC layer, and then actually on instantiation pass in the real repository, database connection, whatever it is you need. And it's going to glue the different layers of our application together. So another thing is an awesome API, well, as an API, it simply has to respond to a request and handle everything in between. Now, a lot of people, before they jump into it, don't realize what all a good API is actually doing. There's authentication, authorization, content negotiation, deserialization, hydration, validation. Finally, you actually get to perform an action. If you think, traditional MVC and actual controller action, something's going to happen. Then you go through a round of serialization, and you may even have more things to do after the request and response cycle is complete. So how are we going to do this? Well, we can finally come to requirement number 3 on our API framework, and that is we're going to use middlewares. And this now really is the reason for this presentation. We're going to talk about how middlewares make it real easy to put together an API and how we use them with micro frameworks. So a middleware is nothing but software that connects other software components. In the terms of an API, what it's really going to do is connect that HTTP request to that HTTP response and do a whole bunch of stuff in between. Middlewares can happen before or after actual routing takes place. They can happen before or after route handling. Again, think controller action, so it can happen once you determine a route, do specific things that apply to that route. And it can happen either before or after the response is set. And that is if you're using PHP FPM and have access to the fast CGI finish request, which we'll talk a little bit more about later. So middlewares, what we're going to do with them is break our code down into many small reusable pieces. Remember, small, simple, easy to test, easy to maintain, generally awesome. So when we put all that together, what we have are essentially micro frameworks. Micro framework, how I identify something as a micro framework versus full stack, is a micro framework glues together a router, a container or IOC layer, and middlewares into a working application. And that working application, of course, is focused on your domain. It's everything your API needs without the stuff it doesn't. So what about full stack frameworks? Well, you can use them if you want, but I'm here to tell you that they're probably the stuff you don't need, especially in an API. All that extra fluff that comes with full stack frameworks can be slower, both in terms of execution time and development time. And we generally, when we get started, want to start with the simplest thing that works. Think agile in this sense. And generally, because building an awesome API is hard enough, without having to worry about all the extra stuff that came with my giant full stack framework. So, a few minutes in, we haven't seen any code yet. What the heck's going on? Well, don't worry, we got some of that. We'll jump right in. So, I got two micro frameworks here. We're going to kind of look at how they're both similar and different. And fair disclosure, the only reason I did that is because back when I started putting this talk together and submitting it to conferences, Lumen had just come out. I thought, oh, well, everybody for some reason gets real excited about Laravel, and Lumen's the next cool thing. So that'd be an awesome buzzword to put into an abstract to, maybe get selected. Well, it worked, maybe. But more importantly, as I really dove into it and started using it, it really doesn't matter which micro framework. You'll find Silex is very Symfony-ish, Lumen is very Laravel-ish, they're slim, Aura, many of them, and they all are generally the same. So pick something that you work with, that you like.
Strategility is PSR7.
What is?
Strategility.
There you go, even better. So as we go through here, you'll see how Silex looks, how Lumen looks, but the underlying concepts are so similar that in future versions of this, I may actually just take one of them out. So a micro framework. This is Hello World in a micro framework. One single file, we create an application, we identify a route, we say return a response that says Hello World, run the application. Now Lumen being dependent on many of the same components as Silex, very similar. Lumen, you instead of instantiating an app, you require it out of a bootstrap that comes preloaded. But same thing, define a route, return a response, run the app. All right, so how about something a little less trivial? In Silex, we identify our services, in this case a repository. In our route, we can inject parameters. We can access those services. Here, this is kind of OAuth authorization simplified. So think I've got a token here, I need to find it to make sure I've got what I want. If I don't have that token, return a response with an unauthorized status code. If I do, go find whatever resource we're talking about. And if I don't find it, 404 not found. If I do, return the response and JSON encode the stuff. Lumen looks very similar. You see bind up there, that's a little different. We'll talk about that in a little bit. But I identify resources, routes, access them, return responses with different codes. That's cool. I didn't need like 30 files to put all this together. I've got like an actual working thing here in a few lines of code. But that's a trap. This is a common micro framework trap right here. Let's look at this again. How do I know this works? How am I actually going to start testing this? Look at all these things I'm doing here. Wait, I'm mixing authorization with finding the resource. How do I put that actual response together? It's a trap because you're just doing too much here. You're mixing your concerns. You're crossing your layers of your application. We want to break this down into smaller bits that are simpler, easier to test. On top of that, I can't even test this without firing up the entire application, right? I got the main application here in a route that, with the method I have to execute. I can't even unit test this. This is obviously, has to be a functional or integration level test. Same thing with Lumen. Too many things going on all at the same time. So a better way to handle this with micro frameworks is actually, they have controllers, and you can use them. So it gives us a little bit of encapsulation. In Silex here, we can define the controller as a resource, and then just call that controller with the get action, get method. And now I've trimmed it down. So where did all the rest of that code go? Well, I've hidden it in the class. I can now inject that repository interface, so I can mock it, or stub it, double it, fake it, spy it, whichever one is correct. And then I have a simple public get action that I could actually call from a test, make sure it did what it was supposed to. I've now encapsulated in a class a bunch of code. Now, as we get into it, you'll see I'm still mixing concerns here. Finding a resource is not the job of a controller action, and I probably don't need to be doing my serialization here either. Lumen controllers are very similar. I mean, this is seriously one of the biggest differences between Silex and Lumen is Silex had a colon there, Lumen has an at. That's how similar some of these things are. Lumen controllers extend a base Lumen controller that gives you some extra functionality if you want it. But the same principle applies. I'm injecting a repository interface. My container will resolve that dependency. And then I've got a simple public action that I can unit test against. Now the container, that IOC layer, is a little different between Silex and Lumen. This is the actual Silex class definition. The Silex application class definition. Silex extends Pimple. Pimple is the dumbest, simplest dependency injection container I've ever seen. It's just array access. You set things in the container that could be simple parameters, a function that will be invoked when you instantiate it. You can use the share method to make sure something's only instantiated once. And of course, you access those things in the container using simple array access. Lumen, its application uses the Illuminate container. So, many similar things. I call instance to create an instance. Bind will actually allow me to invoke a function. Singleton is what instantiates something so that I only get one copy of it. I can bind an implementation to an interface. And I can access it both with array access or using the make method. But since it's Illuminate, Lumen gives you a few more things. There's auto-resolving. You saw that there with the bind. I don't have to actually define what some things are. If it doesn't really have a constructor, Illuminate will just do that for me. There's contextual bindings. So I could say, if you come across this interface, instantiate it with one of these in this case. In this other case, do something different. There's tagging if you need to group your dependencies. And there's even events that you can hook into if you have any need for such a thing when you resolve dependencies. So a little bit more capability with Lumen's container than with Silex. Now those middlewares in Silex are defined pretty simple. You use the service definition where you pass in a string, same thing we were doing with controllers. And you say before on the application if you want to do something before any routing happens. You do method chaining off a route if you want something to happen before, immediately before or immediately after that route. You call after if you want something to happen on the application after all routing is done. And finish will allow you to actually do something after a response has been sent to the server. And when you do those things now, you define those as services and now you have a simple class. So remember we started breaking this down because we want to unit test something. I've now got a middleware that's got a public do something function, but it's got a constructor where I can inject my dependencies. Now this right here is something that's going to be very easy to test. Lumen looks a little bit different, but does the same general thing. You define any application level middlewares by passing an array of them to the application. You define route middlewares in a similar way, and then just for each route specify the middleware keyword which ones you actually want to use. Well, how does that work? How does it know what to apply where? Well, or how does it know how to apply those middlewares before or after? That comes in with how you actually define your middleware in Lumen. You actually use a handle function. So if you do something and then return next request, because Lumen just does chaining of methods here, then you're actually in a before middleware. If you do those things first and grab a response, then perform an action, you're in an after middleware. Finished middlewares are called terminable middlewares in Lumen, and they're different because they have a terminate method. That's all there is to it. All right, so A few examples of how we actually apply those middlewares to all those different things that an API actually has to do. First, we have authentication and authorization. This is making sure that a user is who they claim to be, but also that they are allowed to do what it is they're trying to do. Now, instead of actually having this as repeated code in every controller action like I showed in those non-trivial examples, we're going to abstract that into a middleware. We're using Lumen for this example. So we're going to define an auth middleware, tell the app that it applies to the myResource endpoint when using the post method. And now all that action that actually needs to get taken to do authorization and authentication can be encapsulated in this middleware class. We can inject that token repository that we needed. We'll handle it, looking for that token, make sure it exists, make sure someone has permission. If we're all good, return next, and head off to the next action. I should point out that anytime you return an actual response from a middleware, it effectively short circuits the cycle, and that comes right out. So another reason why middlewares are cool is if something bad happens, you can abort the entire process, give the user that response, and without having to waste all that processing time doing everything, only to find out it's no good after the fact. So when we do auth, let's make sure we're using the right status codes that we return with our responses. 401 means unauthorized. 403 means forbidden. The difference here is that 401 means perhaps you haven't told us enough about you yet. We don't really know if you're allowed to do this. Forbidden means, oh, we know exactly who you are. Get out. We can use headers for authorization too. There's an authorization header. This is pretty common with OAuth. You'll see authorize headers and then provide a bearer token for authentication. Content negotiation. We do this in our API to make sure computers are speaking the same language. The most common of which is application JSON. But there's a reason to check to make sure that these are doing the right things, because if the client doesn't know what language you're speaking, in this case JSON, how's it going to know how to interpret the results? So in this case, we're using Silex. We've declared a content negotiation piece. We put it before our resource, our route definition. And now it's as simple as, well, call that method. Make sure that the request header, the content type header, has application JSON in it. And if not, we return the unsupported media type code. The right status codes here are they're different. There's 406, which is not acceptable, meaning the response type you've requested is not supported here, or is not one we offer, and also unsupported media type. We want to make sure we're using headers here, so accept. As the requester, say what you want back. As the responder, tell them what it is. Use content type. Deserialization. So this is where we're actually going to convert the raw request data, which is JSON, into a native type in PHP. We don't manipulate JSON, we have arrays or objects. In this Lumen example, here's where we've kind of started compiling these different pieces. Remember, now we had a little piece that did authentication, a little piece that did authorization, a little piece that did content negotiation. Now we're going to do something as simple as JSON decoding. So in this case, we try to decode that JSON data, we got it, and if we can't, we need to tell them, that was a bad request, try again. There are many reasons to do this: malformed JSON, nesting levels too deep. If we can't understand the request, how are we supposed to be able to provide a response? 400 bad request is an appropriate status code here if the JSON can't be decoded. But most importantly, let me back up. You'll see if it did work, and I actually decoded data, I'll only use it somewhere else. So in this case, this is one of the options, I'm going to add it to my container, so that anywhere I actually need to access it, I've got it available further down my middleware chain. So in the container is just one place to put it. You could assign it to your request. In most cases, we're using Symfony, or actually in both cases here, we're using the Symfony HTTP Foundation request class. No reason you couldn't extend that. Give yourself a place to put data. Or in Lumen, we can actually pass it to that next call and just throw it over the wall to the next middleware. Make it a parameter on the next middleware's function. All right, so we've decoded the data. We have something we can actually work with. Now we need to hydrate it. And in this case, that means actually fetch or create the requested resource. Excuse me, sorry. So, in this case, we're going to do the method where I said, well, you can just add it to the request. So we've extended the HTTP Foundation request and said, well, we're going to have an array of the data that came in our request, and we're going to have the actual request that was requested, and provide methods to access those on the request object itself. So when we do hydration, here's an example in Silex. Again, this is just a simple class. It has a dependency in the factory that will generate the resource class we're actually going to use, and a simple method that calls that factory and gives us our resource back. So what we're pointing out here with that factory injected is that middlewares don't do the heavy lifting. Middlewares connect request to response. They provide a place for you to appropriately access your domain services. So let's go back and look at that again. My domain service is my resource factory. That's got all the logic I need to build a resource with the given data, however my business decides that it should be built. The middleware is not doing the building. The middleware is accessing the service, the factory, and letting it do the lifting. When we do some of these things, return the right status code. If somebody's saying, get me resource ID 1231, and we don't find it, 404, not found. Now let's say you're posting to a collection, just to say you're creating a new resource, new piece of data. Well, how do I know what you created is even legitimate? Now this is where we have validation. So does this request that you just gave me follow my business rules? This, I will confess, I find to be the trickiest part of putting together any API, because honestly, this is where most of your business rules apply. You're trying to create something new. How do I know you're allowed to do? How do I know you're allowed to do that? How do I know what you said you want me to put together is even legitimate? You know, you want to register a user. I can't reuse that email address because this one already exists. That's the kind of validation we're talking about here. I'm not going to have examples for this, but remember, middlewares are going to provide access to your domain services. So I suggest leveraging a validation library. Everyone's got one. There's a Symfony component. Lumen and Laravel do similar things. Set up a validation middleware that's going to call that validation service and actually perform the heavy lifting. In doing so, if something goes wrong, it was a bad request, 400. But at this point, it's good to remember, if somebody's making a bad request, tell them why. You'll find it not only helpful for users who can then go fix it, fix their request, use different data, different format, but even as a developer, when you're trying to put it together, you'll catch your own mistakes. One format I've used that I found helpful, application API problem plus JSON. You can look it up, there's a spec that walks you through how you would structure a response to tell someone, this error happened, this is why, this is where you can go for more information. And finally, after doing all those things, we get to the actual action, the thing that the route does. When you say create a new route, where do we actually go do, or create a new resource? Where do we go create? Where do we actually get something? Where do we do what it is you requested us to do? We call it the action simply because if you think back to MVC, we have controllers have actions, that's where the thing happens. Simple enough concept to follow. Now you think back to when we created those controllers, this is all we were trying to get to. This is This is actually, with names changed, a very common action in some of the APIs I've put together. Inject your dependencies, and the action itself is simple. I'm trying to create a new resource, so add it to the database. Return a response. I'm done. That's all the action has to actually do, because we've set up these middlewares before it to take care of who are you? Are you allowed to do this? Okay, what does this data actually mean? Do I have those things? Was that even legitimate data? All that's done before I actually get to doing the thing you've asked me to do. Now we have a whole bunch of status codes, and we should be sure we're using the right one. Remember, 200 is just, all right, cool, got it. 201, if you're trying to create something new, tell them, yeah, create it. 204, if there's just no response to return, that's fine, no content. Where you see this commonly is when somebody tries to delete something. You deleted it, I don't have to tell you anything else, just 204, man. All right, serialization. So now I'm returning a response, but I can't return you a PHP object. We were talking over JSON. I need to somehow translate that PHP object into JSON. And this is where we can leverage some best practices from other people. So don't just reinvent the wheel. Like if you have a resource, say an order has a bunch of products assigned to it. I need to start now using, well, embedded in this order is all these products, and here's how they're represented. Don't make up your own format. There are lots of them out there. HAL plus JSON is a very common one. JSON API. There's even something called JSON collection. If you're wondering, okay, how do I format my data in my API? I highly suggest looking up some of these specs. It'll save you a lot of time and trouble. The cool thing about these is they specify how to actually use hypermedia with links, and you can achieve that mythical RMM level 3. So the very last thing we can do are post request jobs. A lot of times what I'm talking about here is things that don't actually have to happen between the request and the response for that request response cycle to be valid. You want to do the bare minimum to get that response out, and then do all those extra things after. So think something like, I placed an order. If that order is legit, respond, 201 order created. But then I got to send an email to them and say, thanks for using acmewidgets.com or whatever. These are the kinds of things we want to actually do after the response has been sent, after the request is done. They're independent of that request response lifecycle, but doing it correctly requires that you actually have fast CGI. Fast CGI finish requests. Now this is a feature of PHP FPM, so is anybody in here still using Apache with mod PHP? All right, this ain't gonna work for you. Unfortunately, all that's happening in the same process, so your response is just gonna be real slow. Also, you should switch to Nginx and use PHP FPM because you get cool things like this and it runs way faster. So what's really happening when this function gets called is FPM returns the response to Nginx, it serves it off, and the connection to that client is closed. But it keeps my PHP process open where I can do anything now and not have a slow response to the client. It's what finish and terminable middlewares are defined independent of any routing. They require that fast finish to work properly. But often we want to only apply these things to specific routes. I don't want to send a thanks for your order email for every single, just because you've requested a list of products. That doesn't make sense. I only want to send it when you've actually created an order. So one way we can do that is use a route after middleware to register the finish middleware. So what we have here is in Silex, we're saying, when I created my resource, after that routing, do this. And what that do this is a chance to register my finish middleware. Now I can keep finish and terminable middlewares route specific. This is what it looks like in Lumen. Again, created after route middleware. In Handle, we actually have access to the app, in which case we can say, now use my terminable middleware. And of course, that terminable middleware has a terminate function, and it will run after your request is gone. So, TLDR. Micro frameworks are simply a collection of a router, a container, and middlewares. They allow you to put together an application to handle a request, return a response. If you ask me, from experience and conceptually, I think they are the ideal platform for a fast, reliable, testable, and maintainable, and RESTful API. Those middlewares allow isolation of each piece of API responsibility. They break your API behaviors down into interchangeable, reusable pieces of code. If I had one more bullet point, I would just say they are cool and rad. Any questions?
Thoughts on the Open API initiative?
Not too familiar with it, to be honest.
Previously based on Swagger.
Oh,
They renamed, I think, last month.
so are you talking like in terms of documentation? That's what I've seen Swagger used for before.
Yeah. Also, client API generation.
So I can speak a little bit about documentation. I've never used Swagger, but just in general, there are a whole host of tools. API Epiary or something.
Epiary?
Yep. I have several of them that I've used with. Are they the ones that actually make Dread? I can't quite remember.
Yes.
So Dread's another tool for testing an API that will actually keep hitting it, making sure that for a given request you get this response. It's kind of high-level functional testing. And in doing that, assuming that passes, they have tools where you can use that sample request response to generate documentation.
What Dread does is it takes your apiary blueprint and then runs the tests using the code that you have in your blueprint. So your blueprint's the documentation, and in that way, it's always ensuring that your documentation is in line with the actual responses you're.
Exactly, except the blueprint is marked down and generally ugly, and so they have tools that will take that and make nice, pretty, nice, pretty web accessible documentation.
Does anyone know of any tools that you can use to test if your site can handle a DOS attack?
I've only ever used Apache Benchmark. You kind of want to get to for a given, it becomes tricky because for a given server capacity, you can handle these requests at this rate. Then you get into DevOps and server architecture, and okay, now I'm load balancing these multiple servers, and so you start hitting that, and it's going to go up because you generate these cycles. One thing I'll say to that, why I like this middleware approach with things like APIs, is that remember I said when you return a response, even from a middleware, it's done. So usually somebody's not authenticated. If you're doing that very first, at the very beginning, and they're passing in junk, and you see that token's not legit, you return the response. Meaning that to get to the part where you're doing the heavy lifting and putting stuff together, hitting the database. You'll hit something to look up that token, but you're not hitting the database to fetch complex resources or write into the database because something was created. So an architecture like this at the application level can help that simply because you can spare yourself a lot of processing.
Yep. So one thing that I was a little unclear with was if you're using validation in the middleware, it seems like the validation would change depending on what they're doing.
It does.
So what I guess I'm a little unclear as to what that validation is going to look like.
I guess that's purposeful because it's going to be different for everybody, and it's different for each piece. And I gloss over it purposely because it's literally the most complex piece of. Validation is, technically you have business rules about authorization and who can do something, but that's small potatoes compared to validation business rules. That's everything about why your stuff is related the way it is. So, how you do that, if you really have this going to be specific to what you're putting together, I leave it in here as we have to do this somewhere. One useful way to do it is wrap it around middleware, say, when I get to this step, go do validation. If it's not valid, I can abort early before I've done database things, put things up. And putting it before that action is useful so that you can check, incoming data as soon as possible, rather than waiting for everything to happen and say, okay, should I do this and commit to the database or not? Now you've done it. Sorry, hold on. You raised his hand like 4 times. I keep hopping around.
Do you have a reason for attaching like the middleware to the route instead of in the controller, or is that just not supported by Silent?
Yep. Wait, what do you mean?
I'm only familiar with the Laravel. I'm like wondering if the other frameworks supported attaching middleware to controllers.
The way Lumen does it, which is very Laravel-esque, if you're trying to do the same thing, but you don't attach it to the controller,
Okay.
so you would specify for each route as an action. Really, the only stages are like routing happens at some point. So, is this middleware you're creating application-wide, which some auth usually is, either you're allowed in or you're not. Then you can route, and then maybe I do validation here, but I don't, or I hydrate this way or that way, and you can get very route-specific, resource-specific at that level, and that's really the only distinction. Lumen and Laravel, they've got some shortcuts where you say, this applies to every action in this controller. I think that's what you're talking about. Silex doesn't do that, so you have to actually call it out for each action. Yep.
So, can you talk about full stack API frameworks like AppAgility?
Yeah.
Besides speed.
Yeah, so AppAgility, that's a big one. I guess the way I look at it is AppAgility's there. AppAgility as a framework itself, I think, is to help. Not, it's hard to be a non-developer and use it, but sort of from that side in general, because what you say is, well, here's my data, now go put it all together. And I'm of the belief that if it were that easy, I would have already done it. It doesn't take too long, or it doesn't take much to have so many nuances in your data, in your domain, to where it's just, now I'm trying to mash it into, something. It's like, it doesn't fit, well, now how do I change it? How well can that be updated? So I like to start from this, because as soon as you get big enough and complex enough, you're going to find yourself, okay, I got to do this my way.
But this doesn't account for things like versioning.
No, and I didn't talk about versioning. AppAgility I know has that baked in as a way to handle it, and I purposefully leave it out because versioning can people will debate about it. Some people will say, how about you just never do anything backwards incompatible? So what's versioning now? Other people will do versioning based on request headers, specific routes. So there's plenty of ways to do it. AppAgility can help you out with the way they like to do it, if that were necessary, but there's nothing inherent about a micro framework that says you have to do it one way or the other.
Do you think that, I certainly prefer micro frameworks, and I think PSR7 is going to be the way to go. But because AppAgility is out there today, like, would you recommend somebody still go with one of these other non-PSR7 micro frameworks?
Yeah, I think that's a really good question. They're not Silex, Lumen, some of these others, they're not PSR7 compliant, but conceptually, I think they're more of why PSR7 exists than other things. PSR7 is there to standardize what it means to have HTTP messaging. What does it mean to actually have a request? What are all these things that can be on a request? What does it mean to actually have a response? Those sorts of things. And I think the idea of micro frameworks and this middleware, where you start at the request and you do a little bit to change it, and we can argue about immutability. Well, was that the same request? Is that not? So I have a request, and all that matters is that I somehow get from that request to this response. We do a little bit of this, a little bit of this, a little bit of this, a little bit of this. And I think that sort of like pipelining flow of the request response cycle more conceptually fits with PSR7. Now, it's only a matter of time before Symphony's got, kind of an adapter for their HTTP foundation components that are PSR7 compliant. So I don't think it'll be too long before they start being rolled out as, by default, this is PSR7, that request is now PSR7 compliant. When I do something, I no longer manipulate a request, it's immutable, I'm getting a new version back, that sort of thing. I didn't know if AppAgility does that already, are they?
I work on AppAgility.
Oh, okay,
I've done it since it started.
yeah.
So, can you rephrase the question?
Is AppAgility using PSR7
No, it's
currently?
not, but it's a tool that works today.
Yep.
And so I see it as moving to PSR7 as components.
Mhm.
But there's no road path for it right now. But I still see it as something solid to build from that is mature today.
Yeah, no, I mean, don't get me wrong on AppAgility. I think it's one of those things that really excels at, I've got data, I want to get it out there much quicker than, this can get very big, very complex, very fast. And if it's just, I've got data, I want an API, the fastest path may be AppAgility. The final path may not, but that's easily one way to get there.
If you want to see it, I'll set down with it.
I last played with it beta time, so
I can show you
Yeah,
the
I-
document integration.
cool.
What are you using for your microphone?
What do I use? Silex.
What about your full stack?
I haven't done a full stack in a long time, to be honest. I really like the style of development where on the back end I have an API and then I'm writing, use Angular, rich client apps that are passing data in and out of the API as opposed to MVC. This is a form, this is a form submission, that type of thing. I really like just the architecture of hide everything behind a RESTful API, access it by cookies. Anybody else? All right, well, thank you. Thanks for coming.